So we start on a nice straightforward question. Oxidation numbers across here should be straightforward. So we've got 4 times 2 minus gives us 8 minus. So that's 8 plus divided by 2. This is 3 minus 2 gives you minus 6. So it needs to be plus 5 to give you the minus charge. And these are 4 plus 1s. So plus 4 there, so that needs to be minus 3 to give you the overall plus charge. So the mass of potassium permanganate that's needed to prepare a 250 gram solution with a concentration of 0.2 mole per dm cubed. So first of all, we need to work out the number of moles that we would have there. So that the number of moles in that solution is the 0.2 times the concentration is 0.5, and then we just need to times that by the mass of the potassium permanganate. Units of rate constant, for the recording of this we weren't that far, but this just shows you what you would do if you're watching it after when we did this paper. And in terms of how many molecules, you have to work out how many moles, and then your number of anything is the number of moles times by Avogadro's number, which is on the data sheet for you. So the key bit here is remember to add in all your extra hydrogens so that when you put your formula together you get the right MR there. So the mass over the MR gives you that number of moles. Right, this big question here then, going back to first year work, this is standard type of question answering here. Let's take a look at what we've got. We've got a table with period 3 melting points, period 4 melting points. Okay, straight away melting points equals forces. Yeah? This is not a question about anything else other than forces. That's all you should be talking about when you come this. Melting points, boiling points equal forces. So we've been asked to comment with reasons on the similarities and the differences across period 3 or 4, and we've also been asked to explain the trend in the melting points across. So taking a look at our melting points going across first of all, you should just go through them. Yeah, just go through them and say silicon has got giant covalent structure. All the covalent bonds break when it melts. The other 3 have simple molecular structures, and it's the London forces that break when they melt. So in these questions, always just state what the structure is, what the bonding is, and what type of force or bond breaks when they melt. So that is part of that, but then we've also got up here phosphorus, sulfur and chlorine having different melting points. So go into the more detail that you know about the London forces here. So S8 molecules have got more electrons than P4s, which have got more electrons than Cl2s. The London forces are greatest in S8, then that one, and that's because more electrons means greater London forces. So make sure you've got this statement in just here. And the other thing they'll be looking for is that you have really clearly spelled it out somewhere along the line that the covalent bonds are strong and take more energy to break than the weaker London forces. So make sure there. So you could have that up in this top section up here. You could talk about as all the strong covalent bonds break there, and you could talk about the weak in London forces here, and you wouldn't have to say that sentence. Lastly, they've asked you to compare it to the other one, to period 4. So the main comparison is that arsenic has got a much higher melting point than phosphorus. So that would suggest that arsenic has got a giant structure.